advent of code that unlocks in about 1 minute. So I'm cutting it a little close to the wire, but so it goes.
They do believe in the fantastic.
Alright, let's just go ahead and advertise this on Twitter.
Yeah, this is good.
Alright, the other thing is today, I have a hard stop at 1 hour and 30 minutes. If I can't solve it in 1 hour 30, I'm going to give up and go to bed because it's a weekday. I have to wake up at an ordinary time tomorrow, roughly. So we'll see how that goes. But at the moment, we've got 25 seconds to unlock. I've got the template open, and we'll see what the puzzle brings us. Alright, let's have a look at this. Okay. Alright, here we go. Oh no, we fell into a... Oh, no, we didn't fall into a hole. We need to get back to the current time. Discover the activation system, which runs forever without halting. So the integer underflow executes the program as specified in sections 1 and 2. Okay. Let's see. All right. Introduce a bug while emulating with a scripting language. That's fine. Great. It's the lowest non-negative integer value that causes the program to halt after executing the fewest number of instructions. Non-negative. Okay, so this is going to be a... Ooh. This looks like another disassembly. So let's have a look at what my input is today. And we're probably going to have to mark it up and annotate it again as usual. So let's have a look. Today is definitely a day that I might want to apply the same technique that I applied 2 days ago, in which I... well, let's see. Do I want to actually run it against a real VM? Let's try running against a real VM, see what happens. In the worst case, this will be not too bad, and it will run without intervention, just using day 19's format. Okay. Okay, so we're going to read in day 21.
This is a good time.
And let's assume that we have 6 registers as normal. Okay, that's fine. So let's go and see this. Okay, so that still looks awfully familiar and fine. I should really abstract this into a library when I get spare time. That's not going to be now. All right. So, oh. Right. So I want to verify that this will work, but I can't programmatically check has it halted yet, because that would be the halting problem. That would be not very good. Okay. Well, maybe this is not the halting problem. But maybe there's something that causes it to repeat states. No, that would be too easy. Okay, so maybe not that, but let's have a look at this. Okay, so let's just make sure that I can run this first. Okay. just so I get familiar with the code. Okay.
Yeah, so
Okay. Something like that should do it, and then let's also pass the
yeah, there's
initial
technical
input.
um, but also in general,
Flag int.
like politically, the HK eviction is shaken.
Okay.
Based off
Initial register.
the Russians are making a lot of plays.
And we'll give that the value
We have a lot
1
of
for now.
appetizing eviction targets on
The initial value
in
of
general, it seems to
R0.
really
Okay,
revive,
so that
Xbox
should do it.
kind of slowly
So
sliding into inactivity.
that's going to be initial register.
So there should be a lot more of this stuff going on.
Okay, and let's set the initial register. Okay, and the other thing we need to do is we know that this program has an instruction pointer of 4. So what is IPReg? Do I programmatically detect that? Yes, I do. Yep, there. Okay, good. So let's just try running this. And let's try passing in a super large value. Say, let's try passing in like 100,000.
Wait, you said it's a
let's see.
regional below rate secure server?
Okay, so that's taking a
All
while.
the guides I can find about this are from like 2010 and still
Okay.
the radar site.
So that strategy is totally not viable. So on to plan B. Okay, so let's annotate this. Keeping in mind our handy little manual specification. So these are the types of things that can happen. Let's see. We're going to want to, we know the instruction pointer is 4. Okay. So we're going to number each of these lines. I know that there's a way to do this in awk. I don't really care. Because this is really not that many lines of program. This should not take too long to disassemble. Okay. Okay. Yeah, there's not that much of it. Okay. It's been a while since I actually had to work at such a low level in the system, so let's find out. Okay. So, let's see. Set immediate does, so, okay. R1 is 0, R2 is 0, R3 is 0, R4 is 0, and R5 is 0 by default. And we're going to assume we know what the instruction pointer is, which is going to be R4. Yep, so, okay. All right, now, what's ban I? Bitwise and, okay. So, right now, oh, I see, it's just checking that. Okay, fine. Which we were told it was going to do, so R2 is comparing to store the bitwise and of register A and value B. Okay, so it's just checking. Okay, that's fine. And then it's checking don't know why I'm doing this. I know exactly what it's told me it's going to do, but that's fine. Okay. R2 is equal to 72. Then, right. Okay. What do these instructions do? Oh, I see. Yep. If it's not equal to 72, then we loop forever, because if it is equal to 72, then we're going to skip over this instruction. Okay, that makes sense. So now, this is the main program. Okay. Is that right? Because I'm adding registers 2 and 4 together, which will increment by 1, which sets us to here. Yep, okay. Okay, so R2 is 0. Okay. By the way, again, this one is another disassembly puzzle, so if you are intending to do this on your own, this will spoil you, because I'm going to disassemble it, and I believe every disassembly is roughly the same. So, buyer be warned. Okay. Worry. Or is the immediate. Okay. So. Is 65536. That's going to be okay. That may be important to express in binary. I think it's probably going to be very important. Okay. So what's that? Okay. Now let's see. What do we have? Ands, so
I'm down.
okay. 255. Okay. 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 I wonder what these special values are here. Okay. Cool. Okay, yeah, I apparently did. This is so weird. I swear. Do I have a hotkey that's disabling my audio? Oh, it's the insert key. The insert key is muting, and I don't need that. I've got a hardware mute button right here, so... Yep, thank you for catching it. Sorry. Okay. Otherwise, we continue here. Also, hi, A9. Okay, so... R1 plus equals... adds register age and value B. Wait. Did I get that right? Value A, register B, register A, value B. Oh my goodness, it's so confusing. Okay. R3 plus 1. Okay. All right. Okay, continue disassembling. Disassembling is a different verb than dissembling, as it turns out. Is less than, is greater than R5. Okay, almost done disassembling. Cool. Yep, that's part of the conditional. And that's another one of these weird skips. Okay. Add. Okay. Okay. Jump to line 26. Is that right? Okay, so if it's greater than R1 is 1, then we skip to here. Yep. Otherwise, we execute this line, which skips over to here. Yep. Okay. All right. And then what happens here? 4 becomes 17. All right. All right, so this is where the loop body starts, which is R5 equals 3. Wait, no, R5 equals R3. Is that the only set R in here? Yeah, it is. Okay, fascinating. We may jump into this code. Okay. 4 equals 7. We may jump into this code. Okay. Jump back to line 6. Okay. Okay. Ah. Ah. Right. Yep. Okay, that seems fine. Add registers 3 to register 4. So if they are equal, wait a second. Okay. Then R3 gets set to 1. In that case, we jump off the end of the program, whereas if it does not equal, then we loop. Okay. I think that works. Great. So that's essentially going to be like a continue in the loop. Cool. So what's at line 6? Line 6 is here. So we have a for loop going in here. Okay. Oh, what happens at line 28? Okay. Okay. Oh, wait. No, it can't come from above. What's line 7? Okay, so that's going to be another inner 4. Okay. That makes sense. Cool. Jump to line 28. Okay. That makes sense. So what happens here? Okay. Loop back to line 6. That's got to be there, so... Okay. Got it. Great. Okay, that's disassembled. Now... Alright, what's that doing? Okay. Right, oops. R4 is... Yeah, okay. Loop back to line 17. What jumps to line 26? That happens here. Okay. Fine. And what happens at line 7? Line 7 is the inner 4. Okay. Alright, loop back to line 17. That's in here. Okay. Okay. That seems reasonable. So now... Okay, does that make sense? So... Line 17 is another inner. Okay. Let's see how this looks. Okay, that seems fine so far. Alright. Ah, okay, I see what's going on. Okay. I think I have this disassembled now. Okay. Package main. Port. Okay. All right. Let's see. All right. Okay. So let's see if we can start labeling some of these things. Wait, where is R0 used here? We can always control register 0. Oh, right, they call it input. Yep. Okay, so something like this. Okay, disassemble. That's cheap enough. I trust that to not be a problem. Okay. Great. So let's just indent all of this properly. See if we can make some sense of it. Part of the point of me doing this by hand is also that it makes it easy for me to continue reading this while I make another pass through. Okay. So what's going on here? Okay. And just make sure that this is sensible Go code that lints first before I do anything else. Okay. Oops. How do I do Go built-in? Integer literals. Integer literals, we have... Oh, that sucks. We have... Fine. Okay. Fine. Annoying, but I'll deal. Okay. Okay. Cool. All right, let's have a look at this now. Now does that lint? Good. Okay, so what we're doing is we do the okay, so let's think about this. Okay. So, main program starts here. Set R2 to 0. Where are we doing something to R2? Okay, so R2 is the value that we're manipulating. So I'm going to call it V instead of R2. And I'm just going to delete this code. Or no, I'm not going to delete it. Let's put it here. Okay. Actually, let's simplify that. Okay. So now... Yeah, okay, that gets initialized. I trust that. Okay. So where do we have R2? So what's happening here? So we potentially make this number 65,536 initially. It's R5. Where do we use R5? Okay, R5 gets used there. R5 gets used there. I don't understand this. Okay. Well... Okay, so we're adding some... R5 gets its lower bits masked off. So we're getting the first 8 bits. Okay. Okay. So this is going to be add at most 255 to V. Okay, and then we mask V. What's this value? Oh! Wait, I've got a suspicion here. Okay, let's just note this down just in case. That has a suspiciously close relation to this value here. Yeah, I think there's something going on here. Okay. Where's R3 used? R3 is used there and there, and it's reset over. Okay. Great. Let's try this. Okay. Where is R5 get set? Another way of phrasing this is R5 is less than 256. Okay. So what is this trying to do? Wait, what? Add R3. Isn't that just a constant? That, no, I think I made a mistake disassembling this. Let's have a look again. Okay, so subtract 2, where is set I? Set I 0, 3, 3. Okay. Source value A into register C, so set value. Yep, okay. Add immediate. Add register A and value B. Register A and value B. Yeah, okay, that looks correct. But then I know that that's always going to be 1. Does something ever jump to line 18? I don't think anything ever jumps to line 18. Yep, it doesn't. Okay. Okay. Oh. I see. I got that wrong. There we go. Okay. Now that makes more sense. Okay. Okay, now this makes a lot more sense. And dupe that. Okay, yep, that seems fine. Okay, is there a termination condition in here? Yes, there is. Continue inner. Okay, so that's just break. Yep, that seems fine. Okay. 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 That makes sense. So R3 is just I here. Just because it's an inner counter. Okay. Yep, that makes sense. So what's this doing here? Okay, let's do that. Okay. Okay, but a simpler version of that. Oh, I see. Okay. What does that do? So we're finding the next... Oh, I see. We're finding the next multiple of 256 that's greater than R5. Ah. I see. Okay. Great. Okay. You can replace it with... Wait. That's weird. Yep, weird. Okay. Okay, so if I were to think about this differently, how does this change? Well, let's see. So... Oh.
Oh my god.
If I... Okay. So that's just 256 times R5 divided by 256. Is that right? Okay, so if... Let me also double check that R1 is not used for anything else outside of here. Nope, it is not. Great. Okay. So if I feed in... if I feed in the value 1... then I'm going to, if R5 is 1, then I'm going to get 0. Because 0 has 256 is greater than it, then 1, and therefore I return 0. Yep, okay. Oh, it's not even that, that's just that. Is it not? Because if I feed in 256, then 0 will work. Oh, it's a strictly greater than. So 256 results in the value 1 being returned. Okay, so let's see. Okay, so that's just equivalent to doing... how do I do this? Yep, that's actually fine. Yep. So we're just simulating division because there's no division operator. Right. Okay. Okay. So R5 is equal to... Oh. That's easy. Okay. That makes sense. Cool. So that neatly replaces all of this code. Okay, so I'm going to just save this here in case I need it, but I'm not going to expect to need it. Okay. Got it. Okay. Okay, I think that should do it. So now we've got some awfully familiar looking code. Great. Okay. That seems to be okay. Great, and then we've got some stuff that does execute here. Okay. Slow divide. Okay. Cool. Excellent. Fine. Cool. So now what do we have here? Okay. Oh. We're slowly dividing R5 until it's less than 256. On each cycle here, we divide R5 by 256. Okay. Okay. So... Ah. So what's V? I think I got this wrong. What jumps to line 6? That jumps to line 7. Which we know is this code here. Yep. That's correct. Oh. Okay. How does this change? So V is 0. What changes V? V adds in the value. So weird. Actually, I'm really curious. Maybe this will work fine now that we've replaced the slow divide. Let's try that. Okay. Let's see. Where did I? Oh, fine. Okay. 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 Okay, where did I define R1, R2, and R3? Alright. Let's just take this out of the picture. Okay. Does anything use R2 anymore? Nope. Okay. Great. Okay. Cool. Let's run that. Well, inner is defined and not used. That's correct. That's because I now know I can just do that. Right. V gets always set to the constant. Where is mast and where is R1? Okay. We're using R1. Alright. let's have a look here. What's R5 essentially being used for? Let's print every time we get through this loop what R5 is. So what happens if... What's the value of R5 the first time through the loop? Okay. Actually, what happens if we just check what is this? Okay. It's outputting a bunch of random values. Okay. Fine. Let's just see what values do we see. I think we see this value an awful lot. Let's try that. That's not the right answer. Okay. Wait. The program must halt, and it must execute as few instructions as possible. Okay. Let's see. Okay. Let's figure out what that looks like. So what do these numbers have in common? Oh, whoops. Let's just try some of these. Okay. Okay. All right. Instead of returning true, what we're going to do is... Okay, let's structure this a little bit differently. Okay. So what we're going to do is this. Every time we see a number, we're going to record how many instructions it took. Okay. Yeah, I think that makes sense. Wait, what was this code before? Crap. to return true. I think that was correct. Okay, so okay, right. Right. Right, that was at the end of the code. That's fine. Okay. Okay. Let's have a look at just what this first value is. So I think that results in the fewest instructions executed. No. For register 0. Them to halt after executing the fewest instructions, which should involve, presumably, just happening on the first go. You'd think. That's what I'd think. But yet that isn't adding up. I wonder whether my code is even working correctly. So if I mistranslated anything, then it would be a problem. Okay. So let's have a look. That looks fine. Looks fine. That's just masking. How many bits is this? 8 bits. 8 bits. So I think it's 24 bits. Right. Is it possible for that to ever... does it ever spill over? No, that cannot possibly spill over, so that's fine. Okay. Okay. Yeah. Okay, maybe I got this logic wrong. Okay. What's GTIR? GTIR is set register C to 1 if value A, which is that, is greater than register B. Okay. Okay, so if R5, if 256 is greater than R5, right, then that is 1, which means we skip to line 16 and execute it. Otherwise, we go from line 15 to line 17. Where is line 17? 17 is a slow divide, right. I think this is easier to understand this way. Okay. if it's 0, because 2d6 is less than R5, then we... Okay, yep, that's fine. That makes sense. Oh. Okay. Okay, now this makes a lot more sense. Okay, so we repeatedly... When we're dividing by 256, we're just shifting right to get the upper bits. Okay. Go back to line 18. Where's line 18? Oh. Oh, I see the bug in my code. Got it. Got it, got it, got it. Whoops, my bad. There we go. Okay, now this makes a lot more sense. Now I believe this. Okay. That explains why I was getting the completely wrong answers. Okay. Okay, now I believe my code much better. Okay. Let's try that. Too high. Okay. Starts at line. Right. Okay. Let's see. Back to line 18. Oh. That code was in here. Okay. Okay. Let's just make sure that we got this right. Okay. Okay, I think that goes there. Good. Okay. Okay. Jump to line 7. What was that? Line 7. The end of the stupid thing. I worry I have corrupted the original program I was supposed to run, but we'll check that by hand in a second. Oh. That jumps to line 8. Does that change the meaning of any of that? Yes, yes it does. There. Okay, now this makes a lot more sense. Okay. Check all of my end conditionals to make sure that I'm adding the extra value. Okay. Yep, okay, now that makes a lot more sense. look at the slow divide code again to make sure that I have the for loop in the correct place. Okay, I'm approaching my 130 hard stop, by the way. Okay, so the slow divide was at line 17. Line 17. Okay, I'm searching for that. If it's greater than 5, then we add... Where's 3 and 4? Yep, that's that. Okay. I could potentially jump to line 28. Otherwise... right. I want the end condition of this. So set I... and 27, 17. Oh, wait, doesn't seem right. I 74. Yep. Okay, that's correct. So it's the alternative case here. Yep, and that jumps us to line 8. Line 8 is here. Okay, no, that's a continue. So it's not a for loop after all. Okay. Okay, that seems fine. Okay, that seems fine. Okay. Let's try that. Now I have to have the 5-minute wait of doom. Okay, what have I done wrong? Okay, let's just try. Does this still work if I do this? Curious what will happen if I do this. Yeah, okay, that still works. So that's not the problem. And that did, in fact, go back to line 8. Yep, that's fine. Okay. Okay. How did I do this? What's the lowest non-negative integer value that causes the program to halt after executing the fewest instructions? I'm not sure which of these I'm supposed to tie break on. Is it the fewest instructions or the lowest number? All right, let's try. That just in case. So it could be 938. It won't execute the fewest instructions, but it does cause, it is the lowest value Oh, unless there's multiple ways to get the same number of instructions. No, that can't be, because this program executes deterministically. There's only one way that it can go. This seems super ambiguous to me. Has anyone solved it yet? 142 people. Okay. Okay. Let me just check this. Let's look at this again. What uses register 0? Pretty sure the only thing that uses register 0 is this code here on line 28. Yeah, that's fine. That's correct. Checking register 2 against register 3. If they are equal, then we add 3 to register 4. Yeah, then we increment by 2, which causes it to overflow. Yeah, that's fine. Okay, so that's correct. All right. Right. Yeah, that seems fine. Yeah, I really don't understand how this is not an ambiguous phrasing. Lowest non-negative value that causes it to halt after executing the fewest instructions. Like, I'm happy to total how many instructions I've run, but I'm not sure that that helps. Because functionally, that is 1, 2, 3, 4, 5. Three, 4. Yep. Start tracking this, even though I have no confidence in what I'm doing. Okay, so at that point I've run 2 instructions. This runs 2 more instructions. It's pretty clear to me the only set of values I can possibly get are values that comply with V, which has to be a 24-bit number. So V could be a 25-bit number. Okay. So how does this work? What's really confusing is instructions 6 and 7 seem like they should be in the opposite order. But R5 is R2, and then we assign R2. Yeah, that seems correct. Okay. 1, 2, 3, 4, 5. Okay. that's supposed to go to that subroutine I'll mark as being in here. Okay, that's fine. That starts at assembly instruction 17. Okay. How does this even work? What's changing R5? R5 starts out as 0. Okay. Let's get ORed with that. So that'll generate 65536, yep. What's V here? What does V get used for here? Okay. Okay. You're taking bits off of R5. Okay, fine. I don't even want to know how many instructions that takes. Oh, I don't want to have to simulate this. It's awful. How does this even work? Let's see. That is a minimum of 1 instruction. And that's going to run for 1, 2, 3, 4, 5. 6, 7. Okay, so let's see that. 1 plus 1 plus 1, 2, 3. 1 instruction there. 2, 3, 4, 5, 6, 7, 8. 8 instructions. Nine instructions to do that. Okay. Nine instructions to do that. Instructions. It's always going to be at least 9 instructions. Okay. Going to need to run at least that many times, right? Yeah, that makes sense. 2, 3, 4, 5, 6, 7 instructions. Okay, something like that should do it. Okay. This is definitely a puzzle that is going to need me to work on it tomorrow after getting some sleep, because I am still as puzzled as I ever was. Okay, well, okay, so I think that this value will cause it to terminate, so let's test that. What did they put there? Okay, that's fine. We execute 1, 2 instructions to do that. That's fine. Okay. All right. That seems to be fine. So let's try running it. A20B go. Okay. Oops. Right. All right. Let's see that. So R5 is 0. Yeah, that's fine. Yeah, I'm going to declare failure if I'm not done in 5 minutes.
Does that seem likely?
I think it's possible.
Does it seem likely?
No. This.
Yeah, so it didn't start getting ready for better.
Okay. Okay, well, let's try this. See what happens if I run the assembly. And we can cross-compare those two things. Right. Did I set initial register correct? Yep, I did. Let's try feeding that and see, does it terminate? So it should terminate, but it does not. Why is that? Okay. Hi, RW. That is a lot of people that you've brought with you. Okay. So I think let's... Oh, wait. Oh, now I feel silly. There's an easier way to do this problem. There's a much easier way to do this problem. Oh. Now I feel so silly. We can just say that if we got to line... Yeah, okay. If we execute this right here, on line 30, then we know we're done. on line 30, which is 28. So if our IP reg equals 28, then R2 is the thing we want to compare it against. Okay. Okay, there. That should do it. Let me see, is that right? Yep, that seems correct. Okay. Okay, so I think that should be correct. Okay. Oh, that feels so silly. After executing the most instructions. Okay. So now let's figure out why my day 21 Bravo solution did not work. Let's see that. Okay. So where is my execution differing? So I should be able to check what's happening here. I'm glad that I got part A at least. I'm going to tell my spouse that I made progress. All right. So let's see. So I know that this value here okay. Okay. Okay, let's approach this in a more sensible fashion rather than decompiling. Okay. Okay. So we're going to forcibly override this and say yeah, I like this. Okay. Okay. So now I'm going to add one more in order to force it to skip to the next value. Hi. I think I have it, Ellie. Okay, so let's see what happens here. I'm going to give it a sensible termination condition, like if I will simulate for 100,000 cycles. No, let's make it more. Okay. Okay. And it'll break out. Cool. Now, let's see. Cool. Now, KV range winners. If the highest, if B is greater than highest, input K highest equals V. Winning input equals int1. Highest equals 0. Okay. Let's try that. Great. Cannot believe I didn't think of this approach earlier. Winners. Okay. So it's just going to be make map of int to int. Okay. Winners 2 is not equals 0. Then let's try that. Okay. See how that does. Winning input is not used. Oh, right. Printf terminated that many cycles. That's fine. Winning input. Winning input is okay. Let's try continuing to go higher, because I can simulate that pretty fast. All right. Okay. Let's see if that works. No, that's too low. Okay, that's what I thought. We have to run this for substantially longer, which might require actually getting an understanding of what the problem is. Okay, well. Okay, the other thing that I can do is I can just simulate the expensive part. If I simulate the expensive part, I really want to just get this to work, though. This would be so much better to just run this natively. If I ran that natively, then I could get the answer so much faster. What causes it to halt after executing the most instructions? Wish I understood what this thing did. I am actually going to hard stop myself in 10 minutes. If I cannot get it in 10 minutes, then I'm not going to get it tonight. It's just not going to happen. Okay. So I'm curious why my disassembly output does not match my my input here. What is the value that causes it to halt after executing the most instructions? What would cause an input to be too high? Input would be too high if it were Victor is going to be less than that number there. Previous wrong answer was that. Okay. Let's find out how far through the search space I got. Oh, I got about halfway through the search space. Okay. So I think I can probably actually get reasonably close this way. It's stupid. Let's see. Cycles percent. We want to get I just want to get progress indicators. Okay. Okay, that's taking too long. Let's see, can I do that? Okay, that's too many. Is that going to provide a reasonable progress indicator? Yep, okay, great, so. I'm willing to wait for 100 of those. Okay, so we'll see how that does. And if that doesn't work, then I am going to go to bed. In the meanwhile, be right back. I'm going to go and brush my teeth and stuff while I wait for that to finish. All right, let's see. Almost done. Let's find out. All right. Let's see. All right, let's see whether that's any better. Oh, nice. I brute forced it. It worked. I'm going to clean this up in the morning, but I'm going to declare op success. Have a good night, folks.